How did you get into electronics? Was it through music?
No.
No?
No.
So did music come first or electronics come first?
Probably electronics. It was two different people that got me interested in each one.
Oh, really?
Yeah. Yeah, my dad was probably the influential one with the electronics. And then my uncle, his brother, was a drummer.
So was your dad, was it like a professional thing or he was just a hobbyist that was into it?
My dad?
Yeah.
I guess he just knew how to fix stuff.
Okay.
You know? So, yeah, he wasn't like an electrician, and I wouldn't call him like an electronics expert, but he always thought high-end stereo
Okay.
equipment was cool and stuff like that.
Yeah, obviously, my dad knows how to fix stuff too.
Sure.
He's more on the mechanical side, not necessarily the electronic side.
Mhm.
But you seem like a pretty hands-on guy beyond electronics as
Yeah.
well,
Oh,
fixing stuff around the house.
For sure.
Yeah,
Mm-hmm.
nice. So when I guess when did you start to do that professionally?
Well, professional.
High school, college,
Am I
post-college?
professional now?
I think a little bit.
Yeah. I don't know. I mean, I guess the first job where I was doing anything like that was probably after high school,
Yeah.
and I kind of got into electronics right away. Out of high school, I was working at Multi Circuits in Oshkosh, so that's where they actually manufacture circuit boards,
Okay.
not populate them, just the bare board.
And
Because there's a humongous process that goes into just building those.
what does that process look like?
Well, so PCBs are typically made out of a fiberglass and resin type of material. So they start out with like the raw thin sheets, and they layer them. Some circuit boards have several conductive layers,
Yep.
like sometimes in the middle. Sometimes they're just on one side or both sides. But so they have like this recipe, for what the layers are supposed to look like. And they're big sheets, they might even be like the size of this table.
So it's probably like a 4x8 sheet, just like sheet metal. Like it laser the shape of the circuit board and
Well, that all comes way
That's
down
way
the
down,
line.
okay.
Yeah, so they just start out with like a blank slab pretty much.
Hmm.
So they layer up all this fiberglass and different layers of copper, and they put it in this huge press. And the press heats it up and smushes it down with a crap ton of force, and out comes, like a blank PCB, basically. No holes, no traces, like it's literally just solid copper and fiberglass. And then I don't know every single step, but they use the major steps are like a photo resist layer that it's like a photo conductive liquid, that they spread on, and then they take, the engineering gives them what the trace layout actually looks like, and that goes into a special machine that flashes it, almost like an overhead projector or something, flashes it with UV light, and that gives you like a negative of what the traces are. And then it goes through like an etching process that strips the copper off that you don't want on there, so you're just left with the traces that you do want. And then it'll go through a drilling process. So any holes that need to be drilled, whether it's for like mechanical fasteners or through hole parts where you got the leads of the parts sticking through the board where they get soldered on the other side. So there's a CNC machine, a big old CNC drill machine that goes through and drills each hole one by one, but it does it millions and millions of times every day.
So you were on the production team.
Yeah.
Well, that's pretty cool.
And then after the holes are drilled, then it goes through another plating
Yep.
process where they actually, and that's what I did, which was kind of a weird in-between step that you wouldn't even think would have to be there. But they take the board after the holes were drilled, and they run it through this big chemical process where the entire board gets plated with copper again, and then the tops and bottoms get stripped completely off so that all that whole process is actually doing is putting a teeny bit of copper inside the barrel of each hole that's been drilled in the board.
Were these specific markets and industries, or like power levels, or was it more residential or retail type products,
No,
or
I think
industrial product?
I think that was probably more for like industrial,
Okay.
medical, military type stuff, probably.
So pretty tight tolerances and pretty tight
Yeah.
production
Yep,
processes and
wasn't-
things like that.
It definitely wasn't like a consumer grade products or anything.
So you got an interest in electronics from your dad, and then you started making PCBs at a CM. So at what point did you want to get into the engineering side and designing the circuits and designing the systems?
Well, I always wanted to do that. Like, even as a kid, I just took everything apart. Like, I still do that, but everything. So
I've noticed.
I would scrounge around in dumpster. You know, I'd go dumpster diving for electronics and stuff just to take it apart.
Nice.
Yeah. So I just learned a lot by doing that. You know, you can figure out how something broke and figure out how to fix it. You just learned a lot about how it works. Like, I can remember one of the very first things that I probably ever fixed was so my mom worked at a factory and like out on the floor, and you know, each person had their own little radio. You could have a personal radio, or this was like in the 90s probably. And her coworker's radio fell off her toolbox or whatever and hit the ground and stopped working. So she brought it home for me, and I took it apart, and I found where one of the traces on the corner of a circuit board was cracked, like when it hit the ground. I didn't have a soldering iron or anything, so I took Vaseline and I smeared it in there to fill the gap because it was kind of conductive and it was enough to make it work again. I'm like, oh, I fixed it. It works. I gave it to Mom. She gave it back to her friend, and it worked for a while, she said, and then it stopped working. So she brought it back the next day and was like, no, it's still not fixed.
Did you
yet.
show her the fix?
Well, so after I told her, well, Mom, I don't have a soldering iron, you know, like all I have is this. So she bought me a soldering iron. That was my first iron, and I don't know, fixed the radio and a ton of other crap after that.
So when did you get into the programming side of things? So that's hardware and manufacturing. What about the software side?
Yeah, that came more in college, I guess. I was, you know, I was always interested in computers. I mean, that's a natural, you know, those two things go together a lot. I was dabbling around, like, you know, could I get an engineering degree, or should I go into like computer science? And more or less my math grades made the decision for me. I couldn't get good enough math grades to get into engineering school. We could talk about that for the whole time. I curl up in a little ball and go, but
that would have been me as well.
Yeah. So that whole time I was trying to pursue that and getting into programming and stuff, but ultimately knowing, you know, I'm probably never going to get like a degree in that. And that's when so music was an interest that whole time, but it wasn't up until that point when I was like, you know, well, I can get a music degree and then I'll at least have a 4-year degree in something. So I did that. And then afterwards I went back to the technical college system and then got another 2-year degree in electrical engineering technology.
So was most of the coding and the programming and the software engineering, was that all, you learned that on your own? Was that on the job as you went?
It was both. Like,
both, okay.
You know, once the Arduino platform became super popular amongst like the maker community and stuff, I started digging into that, and that went kind of hand in hand with what I was learning at the technical school, because I was taking as many of those, you know, embedded type of courses as possible, and sort of augmenting that with some C++, which wasn't directly related to like the embedded stuff, but it's the same language, so I just thought it would help. And then right after I graduated from the tech, I got you know, a job doing a bunch of IoT type projects, and every one of those had some component of hardware and software.
Well, IoT, that's an interesting topic right now. How do you define IoT? It's a term that's thrown out a lot and maybe sometimes is misunderstood. How do you think about it?
One giant circuit board. No, not necessarily. I mean, it can range the gamut from just a bunch of small computers. You know, it's like, where do you draw the line between?
And also, what's a computer?
Yeah, exactly. Like computer versus, you know, an embedded device or something. Yeah. It's really, you know, there's a blurry line. It's somewhere in there, and it really just comes down to like memory constraints and things like that.
And the how targeted the function of the embedded system is, correct? Like a computer is a more general purpose machine, where an embedded controller is specific to a function within a product.
Sure.
So
even though a computer could be doing a really specific task, that's just how you programmed it.
Yeah.
But yeah, it's a general purpose type of machine.
So you know, I think about you know, the embedded system versus the computer, and I think back to growing up and helping my grandma with her computer. And really, there was only two things she wanted to do on her computer. One was write emails, and one was compose like letters on Word documents.
Sure.
But she had this whole machine where there was bugs and there's updates, and she had to do all this stuff. Mm-hmm. So you know, with all of these IoT devices, you know, I would imagine that part of the development is how simple and bug free can we make this thing as we start to place all of these microcontrollers and computers and all of this stuff. Mm-hmm. Is that correct?
Oh, definitely. Yeah, that's probably those are the major hurdles you're describing behind, you know, the Internet of Things.
Yeah.
It's like, how do you make it secure? How do you make it easy to use? How do you make it reliable? Those are all really hard things to do when you're talking about physical devices that are really far apart from each other, I guess. Yeah.
So describe to me like the system architecture. So you have a very simple, straightforward computer inside of some device, and then that's on one end of the spectrum. And the other end of the spectrum, you have some type of user interface. The user interface could be audio, like an Alexa, where, you know, the user, it's in their kitchen, they're asking Alexa to play a certain song. It could be, you know, a touch screen like we have on some of our sports consoles and controllers. You know, it could be a computer. If you think about like every kind of stage or abstraction layer along the way, how do you think about that? Because at a certain point, it has to process the information on the computer. It has to decide if it's going to send it to the cloud. Mm-hmm. It has to process the information in the cloud, and then it has to kick it to the user at some point. And that's those are for connected devices in different locations. But how do you kind of break down the various steps along the way?
Yeah, it's there's quite a range, I guess, of different ways you can architect it, depending on, you know, what you need it to do. But I don't know, using like Alexa as an example, that's actually a really sophisticated device. You know, there's a lot of processing that happens right on that device before anything goes out to the internet.
Yep. So in that case, the computer it's taking in sensor data and it's processing it right there, and then that's more or less communicating with AWS via the owner's Wi-Fi. Mm-hmm. And then it's getting processed again at that point, and then obviously Amazon's doing something with the data as well. So that's a case where the device is actually processing the information.
Yeah, quite a bit of it. And that's actually, you know, it's a good example just to illustrate like how you might architect a product like that a specific way versus something else that maybe just has, you know, like I don't know, a thermometer or something that's internet connected, because that's not really doing much processing. It's just collecting the sensor data, like you said.
Storing it.
Maybe not even storing it. You know, maybe not doing anything, just literally getting it out to somewhere else, somebody else's computer. But like, you know, Alexa, the all the voice recognition, as far as I know, is done on the device. You know, because if you're talking about you know, current technology, the way that it is, you know, it's expensive to stream.
There's
things
bandwidth
like
constraints.
audio,
Yep.
yeah, to, you know, to the internet. So, and it still does that. I think it takes, you know, people think like, oh, is it recording me all the time or whatever? So supposedly not, but when you activate it, what do they call it? Like the wake word or something.
Yep.
It'll record the phrase that you say, the phrase that it acted on, like whatever it, you know, it saw that as an actionable input or whatever. It processes it and I'm sure sends it out. I'm not actually sure how. Anyway, somehow that audio does get to AWS, and you can actually go in.
Yeah, you can go and look at the log.
Right. Yeah.
And that's the public log. That's the log they're telling you about. So like you know, we have a Alexa in our kitchen, and it's primarily used for playing music. Mm-hmm. So if you think about if you think about a kitchen in the year 2040 where they want, you know, the refrigerator's connected, the stove is connected, the Alexa's connected, pretty much any piece of electronic technology, the intent is that a lot of people want it connected. That's the Internet of Things. Mm-hmm. So some devices are processing information at the device. Other devices are passing it through, like the thermometer example. You know, I know some of the things that we're developing right now, we're thinking about like edge computing. Mm-hmm. So you have some information that's getting processed in the device, and before it kicks it to the cloud, there's a more powerful computer that's taking in the input, the data, and processing it. What does an edge system look like versus just something that's getting processed at the device, and why would you use an edge computer? Yeah,
well, I'd say, you know, that's definitely the way that products are headed, right?
Yeah.
I mean, as it becomes cheaper to put more compute power in the edge device itself, I mean, it's kind of there's simultaneous things happening, right? So not only is the technology becoming cheaper to do that, but, you know, the internet itself, connectivity-wise, you know, like
you've got 5G,
right?
You've
exactly.
got the Elon Musk Starlink devices, yeah.
All the ways you can get that data onto the internet and connected.
But even with all that connectivity, there is still a big push. So even once we're surrounded by all this connectivity, which we kind of already are, there's still this edge computing push.
Oh, yeah.
Because there's more data that's being captured than can be pushed through.
Certainly
through the
than what's practical. You know? Yeah. So that's and you know, people expect more and better features all the time. Like I want to be able to, you know, I don't know, watch videos on my refrigerator or check my email on my stove or something. That's a terrible example, but as they're trying to pack more features into these products, it really does make sense to pack more compute power into devices that would never have had that kind of stuff before.
Yeah, because like we've talked too on the lighting side, you know, in many cases the incremental hardware cost it's pretty cheap. You know, you can get a pretty powerful microcontroller, or, you know, pretty powerful embedded system, and to get something that's twice as powerful is not like it's that much more expensive. There's some scale there.
Sure.
So do you think that, you know, a lot of companies that are building IoT products, part of the reason they want to get the data is not because they know how to use it yet, but they feel as though at some point in the future they do want to use it? So you have all these sensors, all these computers, and all of these things, and you have an edge computer that's grabbing it locally, it's processing it, and it's sending it to the server. It's not like it's possible to actually use a lot of that stuff present day, but more or less there's a market to use it at some point in the future.
Yeah, that happens all the time.
Yeah.
I mean, that's literally what the entire burgeoning field of data science is built around. It's like there's all of this data that's already there and has been collected forever now, and nobody's known what to do with it, but they have it, give it to this, you know, do something with it. Like there's ROI on the data or whatever. So
and it's happening with the internet, obviously, but now the goal is to continue to replicate that more and more in the physical world.
Yeah, for sure. Yeah, that's a good point. You know, the data science part of that isn't necessarily even like IoT related, but it can be if you're talking about the data that's being collected by these internet connected devices. That makes it a lot easier, you know, to scale these you know, products and collect a lot of data from a lot of different places, I guess. You know, that compared to like a factory or something where you're getting a lot of data from just like one location.
Mm-hmm.
Yeah.
Well, on the simplification topic, or back to the analogy of my my grandma having a more powerful computer than she actually needs based on what she wants to do. You know, we've been talking, you know, a lot about that recently with some of our sports lighting control products. Just making sure that, you know, what we're developing is you know, is useful for the customer, and even if in theory it's possible to do something, does it increase or decrease the reliability of the system over time? Why don't you talk a little bit about just kind of our closed network, you know, WiLL DMX system, and you know, some of the different ways that customers will interact with that, and you know, kind of some exciting things around that topic.
Yeah, so it's, you know, while trying to connect a system like what we're developing is doable, it's not a small task. You know, that's a huge undertaking. So, you know, the benefits of having a closed system are, you know, security is a huge one, right? Because you literally can't access it unless you're physically in front of it. So there's like physical security, which is, you know, I mean, if you think about the cloud infrastructure in the first place, you're really just talking about somebody else's computer, right? It's funny when if you get into AWS and you start learning about how they advertise their cloud services.
And AWS is Amazon Web Services.
Yeah. I mean, not only are they advertising the security of all these, you know, digital connections, right? They literally advertise the physical security of their, you know, their sites and how they've architected, like physically architected their locations around the country and around the globe, intentionally distributed in specific regions.
It's a military risk. It's an intelligence risk.
I mean, exactly. Like if half of their stuff got physically wiped out, like it would still be okay.
Yeah,
things like that. So, you know, I know that's a far-fetched analogy, but even if we're talking about a lighting system, you know, that's disconnected from the internet, you've got physical security there. Anyway, so how do you interact with it? We've been talking about a few different ways, right? So our product has a touchscreen panel built into it, but it also has its own Wi-Fi network coming from the console, so you can access that over that network. So we've got the touchscreen built into the box. We've got a touchscreen that is wireless and external, that you can move around like a computer monitor. And then there's, I guess we're tossing around the idea of physical push buttons. So like a small, I'm envisioning it as like a small key fob type of remote that might just have one or two buttons.
So like an umpire that's umping a small game in a small town.
Exactly.
You know, they can activate different light shows and sequences and levels more or less right from the field.
Yeah. It's what's interesting is, you know, we're trying to build a product that's really got to be pretty versatile to fill specific applications that are pretty, you know, they vary quite a bit. You know, like a small town ball field versus, I don't know, an airport or something like that. Totally different applications, and you're going to interact with that in different ways. So, you know, scheduling becomes a big component for hands-off. You know, like I want to set it, and forget it or whatever.
Yeah, the club soccer fields or baseball clubs, they don't have maintenance departments.
Right.
So they want to be able to schedule things and just automate that process.
Mm-hmm. Yeah, and then to your point, if it's just an umpire or something running a show, and they still need to have some control over the lights, whether it's triggering entertainment scene or something like that, or controlling zones, but they can't run over and get to a touchscreen panel or something like that, then having a physical remote seems to be the way to go for that.
Cool. Well, anything else you wanna run through?
When did you start doing these podcasts, and why? Why do you like torturing people?
That is a great question. We did a few of them before COVID. I think that's the first time somebody's ever asked me a question.
Oh, really?
I thought the podcast.
Was...
But no, so we started doing them really as a way to learn. So, bringing vendors through, bringing, I think we only had vendors, a lot of engineers at our vendors, but just, I thought that there was a disconnect between some of the technology people in our industry and the actual users of the product. So like we interact with a lot of our vendors and engineers at our vendors and people developing these technologies. And in the lighting industry, there's like 40 layers by the time that stuff actually gets into the market.
Sure.
So I thought it would be interesting to hear from the folks actually developing the stuff. And we did a few of them, and then the COVID thing hit, and we shut things down for a while. 550 days? 562.
Who's
so
counting?
Yeah, but yeah, I think, and then also just I think it's cool to kind of discuss different things with team members and learn some of their interesting backgrounds. Like we had Chad on here, and we talked about his firefighting side job.
Sure.
He's assistant chief up in Neenah. Nick, our brewmaster, just to kind of get out of the day-to-day a little bit and learn more about people and
Sure.
Spotlight people that are really pivotal to the WiLL operation. We also have done like 50 or 60 of these for internal. So these are all external. We've done a lot of internal ones for training.
Sure.
So big project, lesson learned, a big win. And it's been a little bit since we've done some of those, but it just sometimes it's easier to document something via audio and video than it is to sit down at a computer and like write a standard operating procedure. It's like
Sure.
just get behind the mic, start talking, start learning. That was kind of the approach. So
well, and it's certainly a format that people are used to digesting nowadays.
yeah, and I think that there's no shortage of podcasts being listened to by folks at Wisconsin Lighting Lab, and it's cool to engage in some of that on our own. And I think a really good goal over time would be to do a couple a week, and then also have other people hosting. So if I can see at some point having a room where there's a dedicated table, and maybe you'll guest host
That
on
would be pretty cool.
some technology topics, and maybe even have a running stream on the site.
Yeah,
But it's
that's a
just
good idea.
I think people are traveling less, people are interacting in person less. So to get to know the company and get to know the operation might be a good way to do it. We've got some cool guests that we're lining up, like non-lighting people, non-WiLL people. Really we want to keep it Wisconsin focused. So Wisconsin, people in the engineering or the manufacturing business, or people that are doing interesting things in the state. But yeah, thanks for asking.
Yeah. Who's going to interview you?
You just did.
Oh, yeah.
Well, anything else? Are we good?
We going to be a band still or not?
Oh yeah. So Brian's a really good drummer, like a really good drummer. So we've had 2 gigs. We have a power trio here at Wisconsin Lighting Lab. We played a Halloween birthday party and the company Christmas party last year. So it's been 9 months since we've practiced. We better
Halloween's
practice.
coming up.
But yeah, so the equipment's actually right over here next to the motorcycle. But yeah, we got to get back playing again.
Sounds good.
3 months till the holiday party.
Yeah.
Cool, man.
Oh, cool.
Well, thanks for all you do,
Yep.
man. Yep. Thank you.
Happy to be here.